Hello, today we're going to review quadratic functions. So the first thing that we learned about with quadratic functions was how to factor. So the first thing we want to do on this first one is find the greatest common factor of 4x squared minus 8x plus 10. Here, my greatest common factor is 2. So if I factor that out, I'll have 2x squared minus 4x plus 5. This would be my answer. For the next one, we want to factor x squared minus 8x minus 20. There is no GCF, so when I look for a greatest common factor, there is not one. And so then we go straight to the area model. Your first term goes in the first box, and your last term goes in the last box. You always want to multiply your first number by your last number. 1 times negative 20 is negative 20. So that means that I'm looking for factors of negative 20 that add to negative 8. And those factors are negative 10 and positive 2. Remember, order does not matter when you plug these numbers into the box. The greatest common factor of this top row is x. The greatest common factor of this bottom row is 2. The greatest common factor of the left side is x. And the greatest common factor of the right side is negative 10. So our factors are x plus 2 and x minus 10. This is my answer. The next one says to factor completely. And so remember, the first thing that you always want to do when you're factoring is to look for a greatest common factor. And here I have a greatest common factor of 5. So when I factor that out, I'm going to have 4x squared. And then I'm going to have 16x. And then minus 9. So 5 is the first factor that we have found. Now we want to factor completely. So now we want to factor inside the parentheses here. And to do that, I am going to use the area model. First term goes in the first box. Last term goes in the last box. You always need to multiply your first number by your last number. So that means that I'm looking for two numbers that multiply to negative 36 and that add to 16. So let's think about this for a second. 36 and 16. So if you're not sure, I'm just going to use some room up here. What I would do is I would make a list of my factors of 36. So I know I have 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So I'm looking for a pair that could multiply to negative 36 and add to positive 16. That's going to be 2 and 18. In order for this to work, 2 is going to have to be negative and 16 is going to have to be positive. Those are going to be the numbers that I put in the missing spaces of my area model. The greatest common factor of this top row is 2x. The greatest common factor of this bottom row is 9. The greatest common factor of the left side is 2x. And the greatest common factor of the right side is negative 1. And so my factors are 5 from my GCF times 2x plus 9 times 2x minus 1. So this entire thing is my answer, including the factor from my GCF. So on the next one, we want to do the same exact process. Your first thing that you're always going to do is look for greatest common factor. Here, my greatest common factor is 3. So I'm going to go ahead and factor that out. So I'm going to have x squared minus 16 left inside the parentheses. 3 is a part of my answer. Now I want to factor completely. So again, I'm going to use the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. So I'm looking for two numbers that multiply to negative 16 that add to 0 because I'm missing that middle x term. And so it must be 0. And so two numbers that multiply to negative 16 that add to 0 are negative 4 and positive 4. In my top row, my GCF is x. In the bottom row, my GCF is 4. In the left column, my GCF is x. And in the right column, my GCF is negative 4. So from the area model, I get x plus 4 times x minus 4. So my answer is 3 times x plus 4 times x minus 4. We also learned how to solve quadratic equations. And so in this first one, I have two factors being multiplied together that equal 0. So I'm going to use the principle of zero products to set each factor equal to 0. And then from here, I can just solve each equation. To undo subtraction, I'll do addition and get 2x equals 1. To undo multiplication, I'll do division and get x equals 1/2. For this equation, to undo addition, I'll do subtraction and I'll get x equals negative 6. Next we have solve by factoring. We have 3x squared minus 11x plus 8 equals 0. Well, my first step is going to be to look for a greatest common factor. And in this example, I do not have one. So then I am going to go straight to the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. So I'm looking for two numbers that multiply to 24 that add to negative 11. And those two numbers are negative 3 and negative 8. Those are going to be the numbers that go in the empty spaces of my area model. The greatest common factor of my top row is 3x. The greatest common factor of my bottom row is negative 8. The greatest common factor of the left side is x. And the greatest common factor of the right side is negative 1. So my factors are 3x minus 8 and x minus 1. From here, I can use the principle of zero products because I have two factors being multiplied together that equal 0. So I can set each factor equal to 0 and solve. To undo subtraction, I'll do addition and get 3x equals 8. To undo multiplication, I'll do division and get x equals 8/3. To undo subtraction, I'll do addition and get x is equal to 1. We also learned how to solve quadratic equations by taking square roots. In this example, I want to get 9x squared alone. So to undo subtraction, I'm going to do addition. And so I'll have 9x squared is equal to 288. Now I want to get x squared alone. So to undo multiplication, I'll do division. And I'll have x squared is equal to 32. Now I want to get x alone. To undo the square, you take the square root. The square root undoes the square and leaves us with x. Whenever you take the square root of a number, it's always plus or minus. 32 is not a perfect square, so I'm going to do birthday cake to simplify it. The smallest prime number that goes into 32 is 2. It goes in 16 times. The smallest prime number that goes into 16 is 2. It goes in 8 times. The smallest prime number that goes into 8 is 2. It goes in 4 times. The smallest prime number that goes into 4 is 2. It goes in 2 times. And then 2 goes into itself once. When you get to 1, you're done. That's the candle to your cake. We're looking for pairs of numbers to be able to leave the square root symbol. Here I have a pair of 2's that can leave, and I have another pair of 2's that can leave. 2 times 2 is 4. This 2 doesn't have a pair, so that 2 is going to stay inside the square root symbol. So I have 2 answers. My 2 answers are positive 4 square roots of 2 and negative 4 square roots of 2. We also learned about the discriminant. Remember that the discriminant is b squared minus 4ac. And when you do this, if you get a number that is less than 0, then that means that you will have no real solution. If you get 0, you will have one real solution. And if you get a number that is greater than 0, you will have 2 real solutions. So in our example here, A is 8, B is 8, and C is 2. So I'm going to plug into the discriminant. So I'm going to have 8 squared minus 4 times 8 times 2. So 8 squared is 64. And then negative 4 times 8 is negative 32. Times 2 is negative 64. 64 minus 64 is 0. So the discriminant is 0. So that means that we will have one real solution. So if we were to solve this quadratic equation, we would get one real solution. We also learned how to solve by using the quadratic formula. To use the quadratic formula, the equation must equal 0. So my first step is going to be to subtract 9 on both sides. So I'll have 3x squared minus 11x plus 7 is equal to 0. Now that this is in standard form, I can identify A, B, and C, and I can plug into the quadratic formula. So here A is 3, B is negative 11, and C is 7. So I'm going to have x equals negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So minus a negative becomes a positive, and then I'm going to calculate the square root. And so I'm going to calculate that discriminant. So the part that is underneath the square root symbol, I'm just typing that into my calculator. And when I do that, I get 37. And then 2 times 3 is 6. So my next step is to check to see if the square root of 37 is a perfect square, and it is not. So I could go ahead and do birthday cake for that. But 37 is a prime number, so I know that there aren't going to be any pairs. So I don't have any like terms. The square root doesn't simplify, And so then that means that this is our answer. We have two solutions for this problem. 11 plus the square root of 37 over 6 and 11 minus the square root of 37 over 6. The last method that we learned for solving quadratic equations is solving by completing the square. To do this, you want your x's on one side and your constant on the other. So my first step is going to be to add 23 to both sides. And so I'll have x squared plus 14x is equal to 32. From here, I can set up my blanks. And now I am ready for the process of completing the square. So my first term goes in the first box. I want this box to be a square and not a rectangle. So I need to cut this term in half. 14x divided by 2 is 7x. The greatest common factor of my top row is x. The greatest common factor of my left column is x. X times 7 would give me a 7x in this top box. And x times 7 would give me a 7x in this bottom box. The number that will complete this square is 49, because 7 times 7 is 49. So 49 is the number that completes the square. We just factored x squared plus 14x plus 49. And when we factored it, we got x plus 7 times x plus 7, which is the same thing as writing x plus 7 squared. 32 plus 49 is 81. To undo a square, I'm going to take the square root. And so I'm going to write this over here. So I'm going to have x plus 7 is equal to plus or minus 9. From here, I have two equations that I can solve. X plus 7 equals positive 9, and x plus 7 equals negative 9. I have one equation for the plus sign, so that's this equation over here. And I have another equation for the minus sign. And so now I can just solve each of these equations. To undo addition, I'll do subtraction, and I'll get x is equal to 2. To undo addition, I'll do subtraction and get x equals negative 16. So my solutions are 2 and negative 16. The next thing we learned was how to graph quadratic equations. And on this example, I have y equals x squared minus 4x plus 3. This is in standard form. To find the x coordinate of a vertex in standard form, we're going to do negative b over 2a. And so in this problem, a is 1, b is negative 4, and c is 3. So I'm going to have negative 4 over 2 times 1. A negative times a negative is a positive. 2 times 1 is 2. So negative b over 2a gives me 2. So I know that 2 is going to go in the middle of my table of values. Before 2 is 1 and 0. After 2 is 3 and 4. And so then you can just go ahead and plug these numbers into your calculator to get their corresponding y values. And so I am just going to go ahead and calculate those numbers. And when you do that, for 0, you get 3. For 1, you get 0, -1, 0, and 3. So I'm just going to go ahead and plot those points. And then once you have those points, you can connect them to make your parabola. This second equation is written in vertex form. And remember, vertex form gives you the vertex. Your vertex is always HK. You want to change the sign of H and keep the sign of K. So here I can see that my vertex is going to be the ordered pair 1, 4. So when I make my table of values, 1, 4 is going to be in the middle. Before 1 is 0, and then -1. After 1 is 2, and then 3. So now I'm just going to calculate these other numbers using my calculator. And so when I do that, for -1, I get 0. 0 is 3. 2 is 3. And 3 is 0. And so then here is my parabola on this one. And then I have the transformations of a quadratic function. So you can see the transformations of a quadratic function when it is in vertex form. Just like with exponential functions, A represents your stretch, shrink, or reflect. And it will be a stretch if A is greater than 1. It will be a shrink if A is between 0 and 1. And it will be a reflection if A is a negative number. X minus H, this tells you if you are going left or right. So you will go left if you have X plus H, and you will go right if you have X minus H. And then the K value tells you how much you are going up or down. It's going up if you have a positive K value, and down if you have a negative K value. And if we look at this next example, you can see that we have an equation that has been graphed for us. Our domain is going to be our X values from left to right. This graph is going to the left forever, so that's going to -infinity. And this graph is going to the right forever, so that's going to +infinity. -infinity to +infinity is the same thing as all real numbers. Your range is your Y values from the bottom of the graph to the top of your graph. The bottom of my graph is my vertex. This is where my Y value is 2. And then my graph is going up forever, so that's going to infinity. So my range is from 2 to infinity. Or I could say Y is greater than or equal to 2. Your zeros are your x-intercepts, and that is where your parabola crosses your x-axis. This parabola does not cross my x-axis, nor will it ever, so I do not have any x-intercepts. Your y-intercept is where your curve crosses your y-axis, and that's right here. And that's, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Your end behavior. So as x approaches negative infinity, we want to figure out what y is doing. And as x approaches positive infinity, we want to figure out what y is doing. As x approaches negative infinity, this is telling you to look at the left side of your graph. The left side of our graph is pointing up, so that's going to positive infinity. As x approaches positive infinity, this is telling you to look at the right side of your graph. The right side of your graph is pointing up, so that's going to positive infinity. Our vertex is our turning point. That's this point right here, which is the point -8, 2. Your line of symmetry is the vertical line that cuts your parabola into two mirror images that goes straight through your vertex. The equation of this line is x equals -8. Our vertex is a minimum value because it is the lowest point of the graph. For interval of increase and decrease, we're going to trace our parabola from left to right. So if I start at the left side and work my way to the vertex, this part was going down from left to right, so this was a part that is decreasing. Here, my x values for where my parabola is decreasing starts at negative infinity and ends at my vertex where my x coordinate is -8. From there, we start to go up from left to right. And so this part is my interval of increase. My x values here begin at -8 at my vertex, and then my graph is going to the right forever, so that's going to infinity. And then our transformations, we have this 1/4 out in front for our a value, so we know that there was a vertical shrink by 1/4. And then we have x plus 8 inside parentheses, which tells me that this also went left 8 units. And then this plus 2 on the end tells me that this graph went up 2 units. The last thing that we learned how to do was how to rewrite quadratic functions into the different forms. So remember that standard form is y equals ax squared plus bx plus c. Right now, this equation is in vertex form. To go from vertex form to standard form, we need to multiply everything out. And so the first thing that I'm going to need to take care of is this x plus 3 squared. X plus 3 squared means x plus 3 times x plus 3. We learned to multiply two binomials by using the area model. So I'm going to take one binomial and write it down the side. And I'm going to take the other binomial and write it across the top. X times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. So right now, for this equation, I have y equals 4 times, and then inside of the area model, if I combine my like terms, I'll have x squared plus 6x plus 9. And then I still need to bring down the minus 11. My next step is going to be to distribute this 4. 4 times x squared is 4x squared. 4 times 6x is 24x. And 4 times 9 is 36. And then I'm going to bring down that minus 11. And so now I just need to combine like terms. And so I'll have y equals 4x squared plus 24x plus 25. This equation is now in standard form. The next question asks us to write our equation in vertex form. Remember, vertex form is a times x minus h squared plus k. This current equation is in standard form. To go from standard form to vertex form, we need to complete the square. And so to do this, I'm going to put my x's inside the parentheses, and I'm going to put my constant on the outside of the parentheses. I need to find the number that completes this square. And so I'm going to add that number into the inside of the parentheses here and subtract it on the outside. And by doing that, we're keeping the equation balanced. And so by keeping it balanced, we're not really changing the equation. Now I'm ready for the process of completing the square. My first term goes in the first box. I want this box to be a square and not a rectangle, so I need to divide my middle term by 2. 2x divided by 2 is 1x. The greatest common factor of my top row is x. The greatest common factor of the left side is x. X times 1 would give me a 1x. X times 1 would give me a 1x. The number that completes the square is going to be 1 times 1, which is 1. So 1 is that missing value that completes the square. That's going to be the number that I add on the inside and subtract on the outside. We just factored x squared plus 2x plus 1. And when we did that, we got x plus 1 times x plus 1, which is the same thing as saying x plus 1 squared. Negative 8 minus 1 is negative 9. This equation is now in vertex form. And then our last problem says rewrite the equation in factored form. This is currently written in standard form. To go from standard form to factored form, all we need to do is factor. First step with factoring is to look for a greatest common factor, and here I do not have one. So then I can go straight to the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. So that means that I'm looking for two numbers that multiply to negative 12 that add to positive 4. Those two numbers are going to be negative 2 and positive 6. So those are going to be the numbers that go in the empty spaces of my area model. The greatest common factor of my top row is x. The greatest common factor of the bottom row is 6. The greatest common factor of the left side is x. And the greatest common factor of the right side is negative 2. So my factored form is going to be y equals x plus 6 times x minus 2. This is my answer.